Hello everyone, welcome to In 5 Minutes. In this video, we are going to see what is rectification. So till now we have seen the application of double integration to find the area. We have seen the application of triple integration to find the volume. So we have found out the area, we have found out the volume. What is remaining? Length of the curve. So when we use integration to find the length of the curve, it is called as rectification. So this is the basic definition of rectification. So how to represent the length of the curve in integration? So for that we have one derivation which you can remember, or you have used, which you can remember. It is a very simple derivation. So we have to find the length of the curve using integration. So let's say our curve is y equal to f of x. So this is some curve. So we will have the curve something like this. Okay. This is the starting point of the curve, which we called as A, and this is the ending point of the curve, which is called as B. We have to find the length of this part only. So let's say the length of this part from A to B is nothing but S. So S is nothing but length of our curve. So it will be integration of something. So what is that something? Let's take 2 points on this curve. This is one point and this is another point. This point is P, this point is Q. So this is a very small length of the curve. So we called it as differential length ds. The coordinate of P is x and y. Since this is a differential length, so the coordinate of Q will be x plus differential length, that is delta x, and y coordinate will be y plus delta y. So this point, that is distance between P and Q in x-axis, is delta x, and P and Q on y-axis will be delta y, because we are considering very small length of the curve. So consider this part only. If you observe this part, this is nothing but triangle where this length is delta s, this length is delta y, and this length is delta x. This point is P, this point is Q, and these two are at right angle. So here we will apply the Pythagoras theorem. We will get del x square plus del y square equal to del s square. I am dividing the entire equation on both the side by del x square. Okay, so I will get del x square upon del x square, which will be 1, plus del y upon del x square equal to del s upon del x the whole square. So this is our basic formula. Now we will apply the limits on both the side. Why we are applying limits? So limits del x tend to 0, 1 plus del y upon del x the whole square equal to limit del x tend to 0, del s upon del x the whole square. This is nothing but basic form of derivative. So this is the basic formula of derivative. So now we can convert this partial derivative into actual derivative, which will be 1 plus dy by dx the whole square equal to ds by dx the whole square. We know this formula from our 11th and 12th standard. Limit del x tends to 0. When we have this term, we can write the complete derivative. These are the partial derivatives. So del s upon del x will be root of 1 plus dy by dx the whole square. So we have found out what is del s, that is ds. Now if we integrate this part, so from consider this equation is ds upon dx. We have to find s. Let's say we have dy and we have equal to something into dx. So when we integrate this term, we will get y equal to something, so that we will get y. What is y? Here also we have ds and we want s. So we will integrate this part. We will get ds equal to root of 1 plus dy upon dx the whole square into dx. Integration, when we integrate these two terms, it will be s equal to integration of root of 1 plus dy upon dx the whole square into dx. So what is the length of the curve? Length of the curve is starting from this point, ending at this point. That is, the limits will be a to b. So our length of the curve is a to b root of 1 plus dy by dx the whole square into dx. So this is the length of the curve when we have y equal to f of x.